Hey guys, how's it going? We're going to go over how to graph exponential functions. Here we go. So, our general process that we went over in class is step number one, plug in those coordinates. Plug in the -1, 0, and 1. Those are the best coordinates to start off with. So we are quite literally just plugging in -1, 0, and 1 into our equation. When you're doing that, I highly recommend using a calculator. You don't technically need one, but you can just plug her in. We're going to be doing 3 multiplied by 2 to the power, and that x right there is getting replaced with -1, 0, and 1. So we'll start with -1 here. It looks like we get 1.5. And if we go ahead and replace that -1 with a 0 instead, looks like we get 3. And if we replace that with a 1, get 6. So we have these 3 coordinates here, -1, 1.5. So -1, 1.5 appears to be right there. And then we have 0, 3 goes right there. And then we have 1, 6 in right there. Now that you've got your 3 coordinates, hopefully you can compare and contrast to your notes. And you can immediately notice that, hey, this is one of those shapes that kind of just goes straight up. So we're going to go ahead and make it go like this and down like this. Now, if you wanted some more accurate coordinates, you definitely could. You could do things like plug in -2. And if you plugged in -2, you'd get like, 3/4. And it turns out it's like a little bit down there. And if you plugged in 2 exactly, it turns out you get 12. So I'm a little bit off there. But this is just a quick little sketch, and that's good enough. However, make sure you are stating, in addition, state the end behavior of the function. So the end behavior is what's happening on the far left and the far right. You could just copy from the notes. However, I don't think you have to. You always want to start off with as x goes to positive and negative infinity. So remember that this guy right here is talking about the right. This one right here is talking about the left. So on the right, the graph is going up. So we would say f of x goes towards infinity. And on the left, it's going towards 0. And there you go. Let's check out the next one. So the next one, we have a fraction. However, the steps are exactly the same. There's not really any difference here. Let's just go ahead and hop right to it. We're going to plug in -1, 0, and 1. And again, you could use a calculator. However, you are able to do these in your head as well. If you did 1/3 to the -1, that's flipping it upside down. So 1/3 upside down is 3, and 2 times 3 is 6. Plugging in 0 there. Anything 0 power is 1, so that's going to give you a 2. And plugging in +1 there will get you 2/3, which if you want to, you could also write that as 0.667, or 0.6 repeating. So we have -1, 6. We have 0, 2. And we have 1, 2/3, be about right there. And yet again, we are ready for our shape, and hopefully we notice that, hey, we are going down towards that x-axis, and we are going up towards infinity, meaning that we can immediately write our as x approaches infinity, as x approaches negative infinity, what our answers are. So on the right hand side, we're going towards 0. And on the left-hand side, we are going towards negative infinity. Continuing on. So you have this guy here, 4 multiplied by 2 to the power of x minus 1. So we are plugging in numbers again. However, because of this -1, we are not able to plug in the same exact -1, 0, and 1 from previous questions. Instead, what we have to do is quote unquote plug in intelligently. So we plugged in originally -1, 0, and 1, but we have this -1 here, which is kind of like taking away 1 from these. So if you took away 1 from those, you really got to add. So we're adding 1 to all of them. So if you add 1 to all of them, you get 0, 1, and 2, and that's really what you should be plugging in. So you really just got to do the opposite of whatever this sign is. So if that's like -3, you'd add 3. If it's +2, you'd add 2. But we're going to be plugging in 0, 1, and 2, and those will give you the best coordinates to plug in. Please note, you could still plug in 0, -1 and 1, you would not get the wrong answer, but it might be more difficult to graph. I'm simply picking the numbers that are going to be easiest to graph, usually. It's not always, but usually. Anyways, if you plug in 0, this particular question, you'll get 2. This one you get 4, and here you'll get 8. And make sure I did that right. Yeah. All right, so you got 0, 2. We have 1, 4, and we have 2, 8. And yet again, hopefully it has obvious enough shape that we are kind of going up like so. And the point, and the reason why I put this particular question on here is to note that this graph here and this graph here are almost identical. And therefore these, like the subtraction one really doesn't matter too much. That 4 in front doesn't matter too much. What really matters is this 2. That's what really matters the most. And it has identical as x approaches infinity. F of x, oops, you can't even see what I'm writing. I apologize. As f of x approaches infinity and as x approaches negative infinity, as it goes left, f of x goes to 0. Continuing on, we're doing exactly the same thing for problem number 4. So in problem number 4, we have that -1, which means you plug in 0, 1, and 2. Plugging in 0 into this particular equation is going to give us 10. Plugging in 1 is going to give us 5. And plugging in 2 is going to give us 2.5. So we have 0, 10. We have 1, 5. And we have 2, 2.5. And yet again, our shape should be nice and obvious. Going towards 0. Going up towards infinity up there. So yet again, as x approaches infinity, f of x approaches 0. And as x approaches negative infinity, f of x approaches infinity. Because again, as you go to the right, this goes to 0. As you go left, this goes up. Only 4 more to go. Now we're on to number 5. So this is the first one that things get a little bit weirder. So let me see, kind of show you why it looks a little bit weirder. For those of you who've only had 1 day of this class period, this is going to be a little bit different because we haven't practiced these just yet. But this +2 is going to move the entire graph up, which means it's also going to change our end behavior as well. Let's check it out. So we're going to be plugging in the same values, the -1, the 0, and the 1. That doesn't change at all. And when you plug in -1 into this guy, it looks like we're going to get 10. When you plug in 0 into this one, you get 6. And when you plug in 1 into this one, you get 4. So we have -1, 10, 0, 6 there, and 1, 4. Just for sake of doing a better graph, I'm going to add more coordinates to this particular problem. You don't necessarily need to, but I think it will help with this one. So if I were to plug in 2 into this equation, let's see what would happen. You would get 3. And if I were to plug 3 into the equation, I would get 2.5. And again, you can use a calculator for these, no big deal. What might not be obvious on this one is what number it goes to. On the other ones, it was really obvious that it went down to 0, but I don't know if you can tell here, but it does not go towards 0. In fact, it approaches 2. The concept is that this one right here, this guy is going to go towards 0 at the end of the question, whereas you'll have to add that 2 at the end. So for this particular problem, we still have the as x goes to infinity. We still have the as x goes to negative infinity. And the negative infinity one is actually exactly the same. It still goes up. F of x does, in fact, approach infinity. However, as x goes to the right, f of x doesn't go to 0. F of x instead goes to 2. And that's it. It's whatever this number is on the outside. Continuing on, number 6. So we have 5 times 2 to the x minus 1. So just like the previous question, now that -1's happening, we actually know that that's what the graph is going to go off to. So that's like our limit, our end of it. But again, we're still plugging in 0, -1, and 1. So plugging in those same coordinates. When you plug in 0, you'll end up getting 4. When you plug in -1, looks like you will get 1.5. And when you plug in +1, you get 9. So we have 1, 9. We have 0, 4. And we have -1, 1.5. Hopefully nice and clear. The graph kind of goes up like this and down like this, but what might not be so obvious is that it again goes towards -1 instead of 0. So my graph might not have been super perfect. Maybe plugging in -2 would have helped just to get a more accurate coordinate. You don't have to do this, but again, I do think it is useful. You'll get when you plug in -2, you will get 0.25. I guess that wasn't too bad. Yeah. I'm just going to leave it like that. I'm going to leave it here. That's good enough for me. Point is, though, as x goes to infinity, f of x still goes to infinity at the end. But as x goes to -infinity, as you go left, you go towards whatever this number was right there. In this case is -1. Let's finish it off. For this one, now we have to do all kinds of extra stuff. We have a different coordinate we have to plug in, and we're going off to a different number. So we are going to have to plug in quite a few different values here. But for this one, we want to plug in -2, -1, and 0. Those will be our best bets. And when you do plug in -2, it looks like we're going to end up with an 8. And when you plug in -1, you'll get 5. And then when you plug in 0, you will get 3.5. And we are going off towards that value of 2. There you go. As x approaches infinity, f of x approaches 2, and as x approaches -infinity, f of x approaches positive infinity, because as you go left, it goes up. We have one last question to take care of, so let's do it. So we have one last guy here. We have a 1/3, a 1/2, fractions abound all over the place. For this one, because we have a +2 there, we want to start off by plugging in -3. We want to do -3, -2, and -1. Probably worth it to continue plugging in 0 as well. This one, I might break down and use a calculator. We'll see. So -3 will give you 1.6 repeating. -2 will give you 1.3 repeating. -1 will give you 1.16 repeating. And plugging into dividing by 12. Oh boy. I don't know, 1 point something, 1 point tiny value. Yeah, calculator time. I have failed. Disappointed. I'm sorry, team. We'll practice more. 083. The 3 repeats forever. All right. And now we just start graphing. So we have 0, 1.08. We have -1, 1.6. We have -2, 1.3. We have -3, 1.6. Oh my gosh, this is like really not enough numbers. Maybe I need to plug in like a -4 here because of that 1/3 is causing problems. I'm gonna plug in -4 as well. If I plug in -4, what kind of number will I get? I will get 2.3 repeating. Did I make a mistake? I hope I didn't. I don't think I did. No. -4, 2.3. This is probably a little better. Either way, I think at this point you can finally get the shape. And we can now write our answer. As x approaches infinity, f of x approaches Again, positive 1, wherever that number is on the side. As x approaches negative infinity, f of x goes up. There we go. We are all done. Have a wonderful rest of your day, wonderful night. Peace out and have a good one.